here comes another video, and this one is 5.5 number 11. And here we go. Here's the problem, solving for x. And let's just look at this real quick here. I have to shrink this thing up. Let me annotate. Okay. Look at what it says right here. The correct choice, answer sheet, complete your choice, and even more important is this. Type an integer or a simplified fraction. Use a comma to separate answers as needed. So, simplified fraction, in the last problem I worked from this section, they wanted a decimal where you rounded. Here, you're required to put in a fraction or an integer. So that's what we have to do. And as you can see here, since I have the correct answer, it's 5, which is an integer. Okay, here we go. Back to the problem. So here's our problem, this one. And what I'm going to need to do is now go and get some rules, because I'm going to need those rules to solve this problem. And the one which I'm going to use in this case is going to be this one right, and let me annotate it so I can circle it. Here, the product rule. And that's this one. So let's look at it, and as soon as I move my window around a little bit, it's going to get rid of the circle, so just keep track of it, the product rule. And look at what we've got here. We've got a plus here, we've got a plus. We've got a log base A. This is log base 10 because there's nothing there. Log base A. A means you can have anything. It just, the requirement is they have to be the same. Okay? So, here we go. I'm going to use this, and what it allows me to do is take m times n. M is going to be x, and x minus 3. So it allows me to multiply this together. So let's see what I come up with. And I need to do a copy. And let's go over here, Control V. And what I'm going to end up with is this. That's what I've got. The x is going to be, it's in the parentheses, and then I'm going to multiply the x times x minus 3. Okay, let's distribute all this stuff. So I need to add another spot here, edit, copy all, and I'll distribute this too. I distribute it. X times x is x squared. X times negative 3 is negative 3x. Okay, right here, and you need to know this because this is crucial for solving these things, is an invisible number. If it has the word log without a number there, that means there's a 10 here. Log base 10. which we're going to use right now. Because we're going to use a property that completely wipes out the logarithm in this problem. It vanishes. So let's go back to our rules. And the rule that I'm going to be looking for is one of the most basic. In fact, it is the most basic. Log base a of x turns into this thing. So let me annotate so you can see what I'm doing here. Oops, don't want to do that. Now look what I did. Oops, not that one. There we go. And let's annotate. And let's go back over to here. Oh, jeez, too many windows open. Annotate. So right here, I've got this A right there. So what's going to happen is the A moves here, and the Y is going to move up here. And what we're left with is just the X. Everything else vanishes. So let's go back to the problem and use this property. And I can't emphasize, this is almost like thinking in terms of using the chess part of your brain, using a tactical, strategic approach, and creative at times, to do these type problems. You have to use these rules. Now, how do you piece these rules together to solve this thing? That is the issue. Okay, let's go back to what we're going to be doing here. And I'm now going to take this invisible base 10 and do that magical move like I just described. And let's annotate it, and let me describe what I'm going to do. Here's the 10. The 10 is going to come over here and take the 1's place. The 1 goes into the exponent spot. And that will essentially remove the log in this problem. Okay, let's get cooking here. And I need to copy this thing. Actually, I don't. And let's do it. Edit, copy, and let's go down here. Paste. So what I'm going to end up having here is going to be this. Raised to the first power, which is just 10. Okay, so what do I have left here? Now it's going to turn into an algebra problem, because all the logs gone, all the misery of logarithms gone, and all it is going to turn into a factoring problem. So let's get edit, copy, and let's paste it here. Control V. Edit, copy, edit, paste. And so what we have here now is going to be x squared minus 3x is 10. That's what you have. You are now going to need to simplify this sum, and you need to subtract 10 from both sides. Like that. The right side over here will equal 0. And I I'm doing this just kind of, I'm not showing all the steps here because you'll be able to rewind it and look at this if you want. Plus it also makes this part go a little faster. Whoa, look at that. And then you factor this. And you're going to factor it to, let's see, x minus 5, x plus 2. Okay. And then you're going to end up with two answers. X equals 5. Come on, you can do this. What's the scoop here? X equals 5. And we'll throw one more in here. X equals -2. Okay, those are our two answers. Notice that over here, x equals 5. Well, what happened to that -2? Right here. Well, something did happen to it. And what happens is, when you substitute this -2 back into the original equation, which you have to do these problems, when you substitute this back into the original equation, which goes into right there, and also goes into right here, you end up with log of -2, log of -5. Logarithms cannot be negative. And if you were to put the logarithm of a -5 in your calculator, it would blow up. That's not quite true. You would get an error. So what you need to do is rule out that -2. You might want to look at that also. What else can't you have in a logarithm? Because you need to be able to substitute these things back into the original equation to make sure that it is indeed a valid solution. And on that note, I think I'm done with this video.